So now, good day guys, Chem 101, the electronic structure of the atom. Now, in those days, scientists they kept on wondering the position or the orbiting of electron around the nucleus. This is an atom. We have nucleus like a center O and we have electron orbiting it, orbiting the nucleus. Like they are outside. Inside the nucleus, we have the proton and the neutron, but the electron is actually outside. The proton is positively charged. The neutron is it doesn't have a charge, zero charge, while the electron around the nucleus is what? Outside the nucleus is negatively charged. Now, in those days, sorry, let me draw this very well. This is an atom, this is the nucleus, proton positively charged, neutron is zero charge, while we have electron that are negatively charged, negatively charged, negatively charged, orbiting the nucleus. Electrons are inside the atom, but they are outside the nucleus. This bigger one, let's take this as the atom. This is the nucleus. So electrons are orbiting the nucleus inside the atom, but outside the nucleus. Now, in those days, scientists are trying to just explain the figure, like the position, the orbiting of the electron around the nucleus. Like they are trying to just explain it, and they came up with two models. Now, the first model is known as the stationary model. Stationary model. Now, this stationary model state that electrons sit like they are not even moving. They are sitting outside the nucleus. Probably that's why they are able to maintain that staying outside the nucleus. Like the fact that they sit, that's why they are able to maintain staying outside. But scientists discover that electrons are negatively charged and there's a proton inside the nucleus that is positively charged. If these electrons are sitting without doing anything, then this positive charge will likely attract them because unlike charges attract. So they will attract, all the proton will attract all the electron inside the nucleus, then the electron will eventually fall into the nucleus. Do we get? So this model could not describe it because from then till now, as it is now, till we have been giving birth to, we have never had that the electron is attracted inside the nucleus. So and if these electrons are sitting still, if these electrons are sitting still, this one will attract them inside because this is negative, this is positive. But since electron has never been inside the nucleus, that means this model cannot work. Now the second model is the continuous model. This continuous model state that the electrons they they keep on orbiting the nucleus, like they are in constant motion, like they are moving every time, like around the nucleus. Like maybe probably that's why they maintain that position outside the nucleus. But later on, scientists discover that if electrons are in continuous motion around the nucleus, because if you keep on running for hours, you will lose energy, isn't it? And probably you collapse. If electrons keep on moving around the nucleus, they will continue to lose energy since the model is continuous. They continue losing. They will get tired, losing energy until they collapse into the nucleus. And since we've never had that electron has ever collapsed into the nucleus, so this model is also what is disqualified. It doesn't describe the state of electron outside the nucleus. So now, Bohr's model now came in. Bohr's model. Should this spelling be correct? Either of the two, whether this R, okay, I think the second one is correct. The Boss model, B-O-R, R, B-O-H-R-S, or B-O-R-H-S. Okay, I think the first one is correct. The spelling Niels Bohr. The full name is Niels Bohr. All together. So this man made us to understand that, well, though electrons, not that they are not in motion, not that they can't lose energy, but the thing is that they don't lose energy in form of, if electrons are in continuous motion, they will continue losing energy continuously. The word continuously is mean that you are losing energy like independent of time. Like the rate at which you are losing your energy is independent of time. You are losing it continuously. Like just continue. You know, if you are pouring water from a cup, if you are pouring water from a bottle, continuous pouring, like there is no stop, there is no cut. So that continuous model, that's why I could not define it, because they will continue to lose energies, like losing energy continuously, infinitely continuously. But Nesbo said not that they don't lose energy, but they don't lose energy like water. They lose energy in form of pack, like photon. They lose energy in form of pack. That's how electron lose energy. They can emit one photon. This electron, we have energy level, we are still going there, but let me just draw one. Electron here, if this electron want to lose energy, it can lose one photon and jump to a lower energy level. In fact, it can gain it back and jump back. It can lose it, and so there is no in between. Maybe it's losing it small till it gets to this level, small. No, they just like if you have two, you know, Nigeria currency, we have 5 naira, we have 10 naira, we have 20 naira, we have 50 naira. There is no 7 naira. So like you have been restricted to some interval, like a ladder. So electron in ladder 1 can lose energy in ladder 2, in step 2, can lose energy and jump to step 1. It can gain energy and jump here, can gain energy and jump here, but it can never stay in between. There's no in between. It doesn't lose energy in form of water that it loses it small and continuously. It's level by level. So this model, like this model of the atom by Niels Bohr, was able to describe the position of electron outside the nucleus, such that electron can jump this and jump back, jump back, jump back. So that's how electron keeps jumping up, jumping down, until they maintain that outside the nucleus, orbiting outside the nucleus till today. Can we get that? So now, this Niels Bohr model is clearly described using this quantum number. Now, we describe it very well from, quantum number. So the first quantum, we have 4. We have the principal quantum number, quantum number n, the symbol is n. We have, so that one is talking about share, KLMN, OP, we are coming there. Then we have the angular momentum, which is also known as what? Azimuthal quantum number. I think, sorry, I'm trying to remember. That's L, the symbol is L. This one is talking about subshell, SPDF. Now we also have magnetic quantum number. That's when we talk about MS. This one is talking about orbitals. You can have S orbital, P orbitals, though S subshell, P subshell, D and F, they are subshell, but they also have orbitals inside themselves. So this one talks about the orbitals. These are shell, these are subshell, these are orbital. The last one we also have spin quantum number. The fourth one, we have this one as what's that symbol? Yeah, that should be S, spin quantum number. This one talk about direction. So, like, to avoid, we are still going to discuss this explicitly. Let me not speak rubbish English. Explicitly in the next video. But I just want to open like our eyes from the beginning of the history of the electronic structure of the atom. So, we are still going to discuss this guy explicitly in the next Chem 101 video. But for now, this spin quantum number made us to understand that, okay, if you have 2 electrons inside an orbital, this guy is inside this is inside this is inside this. So if you have 2 electrons inside an orbital, eventually they are inside the same subshell and they are inside the same shell. So if two electrons are inside the same subshell, the same shell, the same orbital, so that you won't mix one together, how do we identify them to avoid being identical? That's the where the spin quantum number comes in, that one will spin in one direction, the other spin in the other direction. So that's how we are able to know. So in the next video, we are going to explain this explicitly. So please anticipate the next video. It's going to be very, very wonderful, mind blowing. Don't forget to like and subscribe and share the video among your friends. Thank you.